Now that you've learned how to do the crisscross method to write formulas for ionic compounds, I want to show you today how to go about naming them. Let's review the monoatomic ions first. The prefix mono means one, so a monoatomic ion has one atom with a charge. Remember, your cations are positive, your anions are negative. So the rules for these compounds is that the positive ion is always going to be named first. If you look at the examples of these cations, the cations are really just the name of the element that they're formed from. So Na plus 1 is just called the sodium ion, for example, and Mg plus 2 is just called the magnesium ion. There's nothing fancy about that. The anions, the negative ions, are always going to come second in your compound. For example, the O2 minus ion is made from oxygen, but you have to take the end of the word oxygen off of that name and add IDE to the end. So it's called oxide, not oxygen. Same thing with chlorine. When it forms an ion, it's going to be renamed chloride. Put that IDE on the end. Now here's what happens when we put them together. These binary compounds are made of two elements, and I've given you three examples here, so let's take a look at them. You're going to name the first ion, you're going to name the first part first. So Na is sodium, and then Cl is chloride. The next example is MgBr2. The Mg, remember, is just the name of the element, so it's called magnesium. I'll write that in there for you. And the second word is bromine, but remember we've got to put the "ide" on the end of that word, so this is bromide. Alright, so that's magnesium bromide. The third compound starts with Al, aluminum, so I'm just going to call that the aluminum ion. Name it that. And then I is iodine, but we need to make it iodide. So this compound is called aluminum iodide. And that's how you name these binary ionic compounds. Let's take a look at some larger compounds next. These are polyatomic ions. Now the polyatomic ions are listed in your reference table, so this slide seems like it's got a ton of information on it. But really, this is the same table that's in your reference packet, so you'll be allowed to use that. The polyatomic ions are groups of elements with a charge. Most of them are one element plus oxygen, and their name reflects that other element. For example, nitrite, right here, is nitrogen with some oxygen. Nitrate, also nitrogen and oxygen. It's just got a different number of oxygens. The names of these are going to be the names that you use in compounds. Now these ternary compounds that have more than two kinds of elements are still going to be named positive ion first, negative ion second. Let's look at these examples. The first one is Na2SO4. Now I know that Na is first, so that's the positive ion, and Na is just sodium, the sodium ion. But SO4 you want to start recognizing as a polyatomic ion. So look that up in your reference packet. You'll find that the name of SO4 is sulfate. So this compound is called sodium sulfate. Look at the second one. Now nitrogen's here at the beginning, but H4Cl is not a polyatomic ion. So when I start looking in that list, what you're going to find is that NH4 is the polyatomic ion. And the name of it is ammonium. Write that in there for you. That leaves us the chlorine as the second part of the compound. And that is going to be called chloride. So this compound is called ammonium chloride. Last one, aluminum is definitely the positive ion that comes first, and this one's really easy to recognize because you have the parentheses around the NO3. So I'm just going to call this aluminum. You want to look up the name of NO3 in your packet. It's called nitrate. So this is aluminum nitrate. And that's how you name the ternary compounds. Now there's one other rule or system of naming these compounds, and that's called the stock system, or using Roman numerals in the name. This is not used for every ionic compound, but it is used for all the metals to the left of that zigzag line, except for the ones that you see listed here. Group 1 and 2 elements do not need the stock system Roman numeral. Neither does aluminum, gallium, zinc, indium, cadmium, or silver. So that's just going to be something that takes some practice, but let me show you how it works. Alright, look at these two compounds. There's FeCl2 and FeCl3. Now if we were going to name those, they would both be called iron chloride. The problem is they're two different compounds, and they're going to have different properties. They have different formulas. So we have to figure out a way to distinguish them one from the other. Now, I just put here as a reminder where the formulas have come from. The iron chloride on the left has iron with a +2 charge. The iron chloride on the right has iron with a +3 charge. To differentiate with the Roman numeral, you're going to use the Roman numeral of the charge of the iron. So down here at the bottom, take a look. FeCl2 is named iron 2 chloride because the iron in that compound is iron +2. FeCl3 is named iron 3 chloride because the iron in that compound is iron +3. So remember that the Roman numeral is just the charge of the positive cation, and you only use it for those certain metals to the left of the zigzag that was in the list on that last slide. Keep these notes with you. We're going to do lots of practice. Have a good one.